Hello everyone and welcome to my YouTube channel The Physicist. Please subscribe to my channel. Also like the video and share the video, and please give positive feedback. So in this video we are going to study the reflection of light based on the corpuscular theory. Okay, so for this we consider a reflecting surface as S dash, and let us consider a corpuscle which is coming towards the SS reflecting surface, and it is coming through this path IM. Okay, so according to the theory, this corpuscle starts experiencing a repulsive force when it comes very close to the reflecting surface. Okay, so this distance we can say just only of the order of few atoms, okay, or smaller. So it starts experiencing a repulsive force according to Newton when it comes very close to the reflecting surface, and this force is perpendicular to this reflecting surface. Okay, so now at m we can resolve the velocity into two parts. One is Vx, which is parallel to the surface, and one is Vy, which is perpendicular to the surface. So as the force of repulsion act perpendicular to the surface, so this component Vy will decrease and reaches zero as the corpuscle will come to the point O. Okay, and then it will start increasing and will reach the magnitude Vy, but the direction is just flipped around. Here the direction is downward, but here the Vy, the perpendicular velocity, is upward. Okay, moreover these two magnitudes are the same. Okay, so the particle is now following the path NR, and it is reflected corpuscle. Okay, so here it comes along the path IM, and this is the convex part where the force starts acting. Okay, only in this when the particle is coming through this path, then the force is acting. Otherwise, from N to R and from I to M, no force was acting. Okay, so here the velocity of corpuscle was V, and here it is again V. So as we see, only the y component of the velocity changes, but not the parallel or the x component of the velocity. Okay, so from we also know that we define the angle of incidence and angle of reflection. Okay, what is angle of incidence? It is the angle which the ray makes with the normal. Okay, so we can consider this as the normal, and incident ray making angle with this normal is called the angle of incidence. And also here the reflected ray making angle with the normal is called the angle of reflection R. Okay, so since the velocity, the parallel component, that is the Vx, does not change throughout the motion, so we can write Vx is equal to, in here, this x component of velocity is equal to V times sine I, and here at point N this is equal to v times sine r. So from this, since v sine I is equal to v sine r, so this implies sine I is equal to sine r, and this implies both angles are same. So this is the first law of reflection, which is angle of incidence is equal to angle of reflection. And also see that the incident ray, the reflected ray, and the normal to the plane are in the same plane, okay, which is the second law of reflection. So that's about reflection of light on based on the corpuscular theory. So that's how Newton, based upon his corpuscular theory, explained the reflection of light. Okay, so that will be the end. Thank you.